Children, we are going to start with our new chapter that is called current electricity. When the word current comes into play in our life, it means that is the movement of certain things. We talk about water current in the river, meaning thereby water is flowing. Similarly, when we talk about electric current, current electricity means flow of electron. Flow of electron constitute electricity. Therefore, flow of electron, we say that in a conductor constitute the electric current. Now that electron contains charge. It is a charge particle, basic charge particle of atom, which flows in a conductor. So that charge particle contains charge. Therefore, we talk about the continuous flow of charge through a conductor. That is called electric current, children. Now that electric current, that is qualitative definition of electric current, children. Now quantitatively, how much amount the current is flowing, that we decide by a rate of flow of charge with respect to time, that is Q by T. Q means charge. How much charge? The charge on one electron is suppose E. An electron flows, then a charge is N. Minus we can also say divided by time. The amount unit of charge we understand coulomb and time second. So coulomb by second, better to say coulomb by second CT minus 1. That is called ampere, symbolized as capital A. So that flow of current in a conductor. Now, water flows from high altitude to lower base. We understand very simpler way. It cannot go from lower to high level. Similarly, current also flows under a particular condition. When two bodies are there, suppose A and B, here are A and B. Current flows from A to B when conducted by a conductor. So means A it has higher potential, B at lower potential. Talk about heat. Heat flows from higher temperature to lower temperature. Water flows from high altitude to low altitude, from tank to different pipes and tube. Similarly, if A is at higher potential, higher electrical state, B is at lower electrical state, then current flows from A to B. Reverse can also happen. If B will be higher potential, higher electrical state, and A will be at lower electrical state, then current will flow from B to A also. So that decides the electrical state of a particular conducting body, charged body, maybe a non-conducting body as well. So therefore we say when current flows, it will be flowing from higher electrical state. That electrical state is decided by potential. Is known as potential. What is potential at a single body? It is just to, when we say A is at higher potential, B is at lower potential, means that is nothing but a comparison. A is a higher potential, B is lower potential. But if single body is there, suppose a body is air charged body, so it will have its effect surrounding that one. Certain distance will be there, beyond that one this will not be have any effect. So that will be called infinity. Why infinity कहलाएगा? उस infinity से चार्ज बॉडी तक यूनिट पॉजिटिव चार्ज को लाने में जो वर्क डन होगा, that is called potential at that point, suppose at P. So potential at P will be the amount of work done. So in terms of work done, if suppose Q charge is brought instead of unit charge from this infinity point to this very point P, work done is W. So in bringing Q charge, amount of work done W. So bringing unit charge, it will be W by Q. So potential V will define W by Q. Unit will be joule by coulomb, which is called volt. Now potential difference is also a term. Work done in moving unit positive charge from one point to another point. Amount of work done in bringing unit positive charge from one point to another point, that will be called potential difference. The unit will remain same. Suppose this is the work done is from here to here if you are bringing, and this is suppose at 10 volt, this is 15 volt, so work done will be difference between the two, so 10 volt minus 15 volt, that will be 5, means it will higher potential, this is lower potential, so difference is 5 volts, so unit of potential difference is also volt. Unit of potential difference. Now a term comes resistance. So resistance, what is resistance, children? Resistance is defined as the obstruction offered by the conductor in flow of charge, in flow of current, anything can be called. So that resistance is the obstruction offered by the conductor. Suppose this is the conductor here. Any conductor, current is flowing from surface area, from this very point A to point B, and this suppose cross sectional area is A, length is L. Its resistivity, we can talk about the nature of the conductor. So that resistance means the obstruction offered by the conductor. So this depends on length of the conductor, directly proportional. It will have to cover longer distance, large amount of collision, so large resistance. A resistance is inversely proportional to area of cross section. Larger the area of cross section, lower is the resistance. Therefore, we join together and we obtain a formula R is equal to rho into L by A, where rho is called resistivity. So this resistance and resistivity rho is equal to R into A by L. Different unit of resistance. Resistance unit I will just discuss after this very point. So this is for rho and this is for R. Resistance and resistivity are two different terms. So now resistance depends, and we have a single formula for this one, that directly proportional to length, inversely proportional to area of cross section of the conductor. So this is called resistance, the obstruction. There are two kinds of resistance. One is called dynamic resistance, one is called constant resistance, or which follows the Ohm's law. Ohmic resistance we talked about, that follows the Ohm's law. So let us come over the word Ohm's law. Ohm's law states that, the statement is written in the book, I am just telling you, that the current flowing in a conductor is directly proportional to potential difference between the ends of the conductor, provided physical condition remains constant, meaning thereby temperature and pressure of the conductor remains constant. Suppose we have a conductor here, this one, current is flowing in this very conductor, so it depends that R, what is the potential between A and B. So difference of potential between A and B, that is the current flowing in a conductor statement is directly proportional to V. But mathematical statements stops us to write like this, where V is directly proportional to R. Then V is equal to I into R. This R is actually resistance, which is a constant for a conductor. It does not vary, that remains constant. So that remains constant for a particular length, for a particular area of cross section, and temperature pressure remains constant. Temperature pressure remains constant. So this is our Ohm's law, very important law regarding resistance of conductor. So V is equal to IR. This is very important formula from Ohm's law. Ohm's law fails under the condition when temperature and pressure do not remain constant. So this is about Ohm's law. Circuit diagram can be drawn here for Ohm's law, that we have in a circuit. A circuit means, said earlier, at least it contains a source of current, a resistance, a switch, and a load over there. So this I am telling you a simple diagram of resistance, Ohm's law. Ohm's law is like this. Practical application is also there in Ohm's law. Suppose this is the source of current here. Source of current, a switch we are adding, and then after that an ammeter. Here is ammeter added, and after that the load is here. We can say about the resistance, and then it is wound like this. So this current will be flowing in this one. If the potential difference between these two is V, resistance of the conductor is R, then V is equal to IR. From here R is defined as V by I. So potential here, this potential V has unit volt. Current as ampere. Volt by ampere is called ohm. Regarding the name George Simon Ohm, who gave this Ohm's law, volt by ampere, that is called ohm. So unit of resistance is ohm, meaning thereby in a conductor when the potential difference between the 2 points is 1 volt and 1 ampere current flows between the 2 points A and B, meaning thereby the resistance of this conductor is 1 ohm. So 1 ohm can be defined like this. When at a potential difference of 1 volt, 1 ampere current flows between the 2 points, then the resistance of that conductor will be called 1 ohm.